Hey everybody, today we're going to continue our lesson on the law of sines, and if this looks really weird, what we have right in front of us, that's because it is. It is actually a refresher course from something we did back in, if I remember right, probably early October. Back in early October, we were talking about all the different ways that we could prove that two triangles were congruent. And so back in the day, we had things like side, 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 angle, side, angle, 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 side. We had side, angle, side. And then we learned a lesson about something that couldn't be done. I gave you two triangles, and they had the same angle. I don't remember what this was. It was probably about 30 degrees, if I remember right. Okay, and then this was about 30 degrees. Then the distance from A to B was 3 inches, and the distance from B to C was 2 inches. So anyway, if we go back, this was labeled A, this was labeled B, this was labeled C, then this was labeled D, E, and F. And it was sort of an optical illusion. You know, the idea that we would have two triangles that had the same angle and then two matching sides, and yet they would look so different. They had the same angle, then the same side, then the same side again. But then what we ended up discovering is that angle, side, side is not a valid way to prove triangles are congruent. Now at that point, that opened the door up to all sorts of jokes, because we started talking about how that phrase compared to the other ones. You know, we had side, 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 angle, and we talked about how this one doesn't work, and it's not just because I don't want you to say the word, it was because it is mathematically incorrect. If I give you an angle and then two sides, depending on the situation, there could be two different triangles that fit the requirement. Now, the reason I bring that up today, the reason it fits in with today's lesson, is because we are going to go deeper into the concept of the law of sines. And in our deeper level here, what we are going to end up finding out is that the law of sines usually works really nicely. But today we're going to talk about situations where it doesn't. Now, what's actually interesting about this part of the lesson is that if we end up with a triangle that doesn't have a solution, that's actually great news, because it means we're done with the problem. But then there are also times where you're given a set of information and there are two possible triangles that would meet the requirements, kind of like what happened here, where we had an angle, a side, and a side that matched, and we ended up with two different answers. Now, this concept is something that even the pre-calculus kids don't like. Usually in a pre-calculus class, less than half of the class will really understand what's going on. So we're going to break it down. We're going to do 3 examples. And I'm going to tell you right now, one of the examples is going to have no solution. One is going to just be a regular example that has one solution. And one is going to have 2 possible solutions. So we're going to talk about when to know and what to do about it. All right, so let's take a look here. Let's fill in the table with the information that we have. That way we can get it all sorted out. Okay, we got that, and that. It did not give me a unit of measurement, so I'm just not going to worry about it on this type of problem. And then we are going to set up the law of sines. And we're going to say sine of 36 over 2 equals the sine of big C over 7. All right, we're going to cross multiply and we're going to see what we can do. We're going to get 2 times the sine of C equals 7 times the sine of 36. And then we're going to have to divide both sides by 2. All right, so let's get the calculator out. Check your mode, make sure it's in degree mode. Ours is, and we are going to get 7 times the sine of 36 divided by 2 would put you right there. So that's what we're going to have. We're going to have sine of C equals, oh, let's look. Now we're going to leave that in the calculator, but I'm just going to take notes here. Now, as a math teacher, I already know that this is a big problem. You might not know it yet, but we're going to find out here. Remember, whenever we're trying to find a missing angle, we're going to use the inverse function. So the inverse sine of the answer, which was 2.0572. And what in the world just happened? Why did it give me an error? I guess I'm going to go to it and see what's going on. It's the sine of, in case you forgot, this number was about 2.0572. Let's see. Okay, why does it keep giving me an error? All right. It turns out example number 1 is not a triangle at all. You cannot make a triangle that fits this requirement. And it actually goes back to the original definition of the sine function. You know, I don't know if you remember this or not, but we talked about how, and I know you'll remember it once you see it. We talked about how sine was the ratio of the opposite side to the hypotenuse. Well, let's just make up an example. Let's say 10 over 7. If you're talking about a right triangle, can the opposite side be bigger than the hypotenuse? Well, no, of course not. The hypotenuse is the biggest side. If you look, sine cannot be bigger than 1. The sine of any angle in the world cannot be bigger than 1. Which means if you get a problem like this where you're trying to solve for an angle, and so you have the sine of C equals 2.0572. As a teacher, I already knew that that was going to be a no-go. That number cannot be bigger than 1. If it is, then the information given is not going to make a triangle. Okay, so keep that in mind as you go through. If you end up getting a ratio bigger than 1, then that is your signal that the problem is not going to work. And again, I already told you, I'm happy when this happens because that means less math to do. All right, so let's go through and let's do problem number 2. Now, before I do example number 2, I want to do one last little calculator demo with you. I want you to type in on your personal calculator sine of 20, and then I want you to type in sine of 160. Pause the video if you have to, or if you don't have the calculator handy, I guess you can just watch. Okay, sine of 20, 0.342, sine of 160, 0.342. I wonder if there's a reason. Let's try this again. Sine of 40, and then sine of 140. Okay. Yeah, we might be up to something here. Let's try this again. Sine of 62 and the sine of 118. All right, this is getting ridiculous. Why in the world is it doing this? I don't know if you noticed the examples that I'm giving you are all supplementary. They all add up to 180. That secret right there is actually what's going to lead you to the answer to problem number 2. It's the dark secret that you don't really get into until you get into higher level math classes. It's the idea that there might actually be 2 triangles that meet the requirement. Okay, so this is where your spoiler alert is going to come in. We're going to go, whoop, there you go. Example number 2, we are about to do right here, has 2 possible answers. Okay, so this is the one that's going to be obnoxious. Now, I want to show you how we can get both answers here as we go. All right, so let's fill in the information first. We're going to do the problem, and then I'm going to talk about how you'll know if it's a possible 2 triangle situation. Okay, so we got 13, and we've got 10. And then that exact same information is going to be repeated right over here. Okay. Okay, so let's go through and let's set up our work. And let's say sine of 32 over 10 equals the sine of A over 13. Okay, so let's do this, and this, and this. All right, there you go. So we set this up, we cross multiply, we're going to get 13 sine of 32 equals 10 times the sine of A. And then we're going to divide both sides by 10. Okay. And that's going to give us, all right, 13 sine of 32. And then we divide by 10. So it turns out the sine of A is 0.6889. You don't have to write that down right this second. I mean, you can if you want. But in the end, we're just going to leave that number in the calculator, and we're going to get that the missing angle, remember, whenever there's a missing angle, you need to do the inverse sine function. And that was what? 43.54 degrees. I'm going to have to move this over so I have room to put that in there. Sorry about that. Okay. Now, here's the catch. This is where things are about to get weird. What if that's not the only angle that would work? Remember that demonstration we talked about at the very beginning about how sometimes there are actually 2 triangles that meet the same requirements. If that happens, you have to find both possible answers. All right, so let's get back into the calculator here. So we talked about how if you do the sine of 20 and the sine of 160, you'll get the same answer. Let's try that with what we had earlier. we know that angle A is 43.54. So the sine of 43.54. What if you did the sine of the angle supplementary to that? You know, the angle that would make the pair supplementary. So that would be 136.46. You get exactly the same answer. So the question then becomes, what if it turns out angle A is actually obtuse instead of acute? So we have to consider both the possibility where angle A is acute and the possibility where angle A is obtuse. Now, a little editor's note here. If it turns out that this plus this add up to something more than 180, then you don't have to bother with that second triangle possibility, because obviously triangles can't add up to more than 180 degrees. Now, in this particular case, everything checked out because triangle 2 has two angles so far, and they don't add up over 180. So this is sort of our worst case scenario if we're being completely honest, because it means we're going to have to do both solutions. All right, so we're going to do 43.54 plus 32. We're going to take that away from 180 to get angle C. So triangle 1 is going to have an angle C of 104.46. Now triangle 2 is going to have an angle C of 11.54. So obviously we've created two very different scenarios here. So now our final step is to take our law of sines that we did earlier, and we are going to apply it to angle C to try to finish up the problem. And like I said before, we're going to have to do it twice because of what happened here. We're going to have to do it once for the first triangle, and then we're going to have to do it once for the second triangle. All right, so when we do it the first time, we're going to get 10 times the sine of 104.46 equals C times the sine of 32. And then to solve for C, we're going to have to divide both sides by the sine of 32. All right, so that should give me that. We'll throw that in the calculator, see what we get. And in this scenario, side C is 18.27. All right, now we're going to do the problem one more time. So this right here was what we had to do to finish triangle 1. Now we're going to do what we have to do to finish triangle number 2. Now this one had a little teeny 11.54 degree angle instead. Okay. So essentially this is the work that we had to do to get triangle 1. And then this over here is the work that we're going to have to do to get triangle number 2. Okay, and that's going to give us let me fix that for you here real quick. There you go. And then the same idea from there, you're going to divide both sides by the sine of 32. All right, so let's try this one now. Oh, that wasn't exactly what I wanted. And you get 3.78. Now, of course, when you look at that, you realize that we've got two wildly different answers here. But they are both possible answers given our situation. Okay, so we have triangle 1 and we have triangle 2. They are both possible solutions. All right, let's talk about example number 3 here. All right, now as I type in the information in the box right here, you know, where angle B is 106 degrees, side A is 17, and side B is 25, I am already relieved. As I'm going through looking at these numbers, I'm already really happy about what I see, because I know for a fact that I'm not going to have to do that crazy two triangle stuff. There's only going to be one possible answer. Now, how do I know? Well, remember, in example number 2, we talked about how there was an acute possibility and an obtuse possibility. If you already have an obtuse angle, that's good news, because triangles can't have two obtuse angles. So as soon as I solve for angle A, I don't have to worry about if that angle is acute or obtuse, because I already know it has to be acute. So we can just go on and do our normal thing. All right, so let's do it. We're going to take the triangle that we know everything about, and we're going to say sine 106 over 25 equals the sine of A over 17. And then we're just going to go through and we are going to solve. So 25 sine of A equals 17 times the sine of 106. And then we divide both sides by 25. We hopefully remember from our first example that we do not want that number to come out to anything greater than 1. So we have 17 times the sine of 106 divided by 25. In case you're wondering, it does check out to something okay. 0.6537. And then remember, if you want the missing angle, then you're going to have to do the inverse sine of what you just got, and you get 40.82 degrees. All right, there you go. So again, that trick about supplementary angles that we did earlier in example number 2, we don't have to worry about because the obtuse angle was already given to us. So now all we have to do is, instead of worrying about that second one, just go through, take what you've been given, take it away from 180 to figure out that angle C is 33.18 degrees. All right, let's finish up the problem. Remember, we don't have to deal with 2. We're just going to do the 1. We're going to use the first part of the law of sines that we used before. No use in reinventing the wheel. And then we're just going to take the part that we want to know here, sine of 33.18, over little c. All right, we're almost done. 25 times the sine of 33.18 equals c times the sine of 106. And then we will divide both sides by the sine of 106. And we'll finish this deal off. Now I did round a little bit here, so if you get an answer very slightly different than mine, it's not a big deal. You are still good to go. You get 14.23. All right. So let's just go over 2 quick thoughts here before I end the video for the day. Thought number 1, a good way to check your work as you go, and we've talked about this briefly before, is to make sure that the small sides go with the small angles and the big sides go with the big angles. So if you look at example number 3, the smallest angle was C, the smallest side was C. The biggest angle was B, the biggest side was B. That should always be the case, no matter what type of problem you're dealing with. Even in the example that had 2 possible solutions, it still held true. Smallest angle, smallest side. Smallest angle, smallest side. Biggest angle, biggest side. Biggest angle, biggest side. That's always going to be the case. Okay, so that's the first thing I want to make sure you know when you're going through and doing some error checking. And that can actually save you some time in the future, nudge, nudge, wink, wink, hint, hint, when you get to the bottom of this worksheet. Now, the other thing I want to bring up, because this was a pretty overwhelming lesson in general. There was so much going on here. How do you know when to do this whole thing where we have to check for 2 triangles and all that? Now, please don't write this over your number 4 because I want you to do the problem. But I'm just going to type it here so you know. When to look for 2 possible triangles. Well, first of all, as we talked about earlier, the situation that creates all the problem is angle side side. So you automatically know that you've got a chance if it's an angle side side problem. Now, the other thing that you can do to save yourself some time is to check the angle that's been given to you. If the angle that was given to you was obtuse, you can't have more than one obtuse angle in the same triangle. So, the only time you really have to check for 2 possible triangles is if the given angle is acute. So essentially, you've got 2 rules here. Rule number 1, you're looking for an angle side-side problem. And rule number 2, the angle is acute. So angle side-side, and the angle is acute. Angle side-side, and the angle is acute. When those 2 things happen, that's when you know there might be 2 triangles. Okay, so that's what I want you to keep in mind. All right, I hope that helps you get going. There are a few more problems down below it. Number 7, I don't actually want there to be any math done, I want it to be something that you think about and process, because if you think about it for a minute, you'll be able to figure out what I'm getting at. So, I hope you have a great day. Take care of yourselves, take care of each other, and I will see you next time.